Thank you very much, Dimitri. Great to be here. So we want to kick off really this webinar with a bit of a reason for why do we need essentially enterprise XR. So how is enterprise
there
XR?
You are. I was waiting for your camera, my friend. So I'm glad you made it. So explain us about the drivers of VR in the industrial setting, and go ahead.
Yeah, certainly. So, I mean, this will be a diagram that's familiar to many people who obviously operate, particularly in the manufacturing engineering space. So this is ultimately how we see, certainly at Virtalis, the product value chain, but more importantly, how we see where virtual reality fits into this model and acts as a solution and ultimately an enabler to some of the things which we need to achieve in modern engineering and manufacturing processes. So if we start off with some of the challenges, many of you will be obviously familiar with these. We have a need now for global connected supply chains. So we're no longer just dealing with in territory or even local manufacturing facilities. We have teams and parts of manufacturing process distributed completely across obviously across the globe. In addition, we're getting more complex products. We're seeing within manufacturing today. The complexity of some of the parts and the systems and how they're being pulled together. You're dealing with hundreds of suppliers, again, completely across that supply base. And ultimately, we're moving to a scenario where we have to move to much more lean manufacturing processes. So how do we start to look at ensuring we've got this constant feedback cycle as part of the product design process, and even during the manufacturing of that, how does a product continuously evolve to design challenges that we're seeing both during manufacturing stages, and then even as we move on, we start to look towards digital twins, how we're actually seeing data come about from real-time information that we're seeing directly within the actual life of that product. I think one of the key themes as well, which we're certainly seeing from a Virtalis perspective, is how do we essentially reuse data and reuse that information contextually and visually across all elements. We see very much VR providing a key role in not only starting off at the very beginning during design cycles, but actually also reutilizing those visual assets throughout the life of the product. And this can be seen, for example, in training scenarios. So how do we onboard people within the field to actually be able to view and see this information, through to, as we've discussed before, the concept of digital twins. How do those virtual models continuously update throughout the life of that product? And the way we've kind of addressed this as an overall solution is what we call the Virtalis VBOM, so a virtual bill of materials, essentially, that sits within there, and is fed from numerous different data sources throughout the product lifecycle. So straight away from PLM systems, where we're importing data in real time from various different CAD importers and product lifecycle management solutions. We're seeing real-time unstructured data imports coming from IoT data and sensors, which we're seeing in the real world. The ability to import and provide extra contextual and real-life information from data sources which are not necessarily akin to simple CAD models, but bringing stuff from LiDAR sensors, point cloud information, bringing all that information into the model, and even geoscience data. So how, from a manufacturing perspective, do you start to actually see this in live as a complete virtual environment? And one of the key principles as well to all of this is having that connectivity and that extensibility. So how do we make sure we have a solution which provides an open API construct, so you can manipulate information going into the virtual environment, and equally how you can actually extract information from it throughout that entire value chain. That's not to say this isn't without challenges, and we know many of the challenges which we see today and have addressed as part of our product offerings and solutions at Virtalis. We have seen and operated against the huge models and huge data sets requirements which are coming in, and the need to be able to see everything from an entire virtual world, an entire ship, an entire plane or aircraft, through to this smallest minute detail, all within one model. And to do that in real time, to do that in a way that doesn't require expensive time spent by engineers on each import, but how automation is introduced into the process to actually make sure that what we're doing is implement once, reuse many as part of that solution. And the other thing, as we've said before, this world is becoming a connected world across the supply chain, across the enterprise. How is information and data kept up to date, consistently in one place, and consumable by many different departments, depending on the context in which that department wishes to consume that information. To address some of these challenges, what we've created as one of the core software pillars of Virtalis is Visionary Render. Visionary Render is the core authoring environment and visualization facility where we create and obviously operate model development within there. One of the key features and capabilities of Visionary Render is the ability to interact with huge models and data sets. So that ability to see entire ship solution, or entire aircraft, down to the smallest rivets within the body and within the structure. And that's important because that reduces cognitive load. So from a point of view of people working on this, either from a training scenario or from a design review scenario, they can see this in essentially real life through a virtual environment and understand how things will actually operate as it becomes the physical reality manifestation of that product. Key benefits to that is obviously you're identifying issues early in that supply process and in that design process. You can see problems before they go to build, which obviously reduces risk, certainly from a project perspective. It allows rapid iterations, the ability to constantly change prior to actually committing any physical build against that. Key drivers and ROI against that is not only time, it's also obviously investment in the, let's say, pre-tooling and other information, obviously which you've gained as part of that process. And the other thing, another kind of key ancillary feature that sits around this as well is part of the rich feature set of Visionary Render allows you to apply various different solutions such as textures, lighting to make the models realistic and very relevant for people obviously operating in the environment. Additionally, you can also embed other documents, other contextual information and assets that you may have available, particularly relevant in training scenarios. There may be checklists, PDF manuals, or even embedded videos that can also be displayed within the virtual environment as part of that training solution. So next up, let's talk about some of the key use cases in which XR is relevant, particularly within manufacturing engineering. We've talked briefly about design reviews, so actually being able to understand and see very early on in the value chain what is obviously working, what is correct, what needs to be changed and modified during that process. Virtually prototyping those assets, so being able to essentially see and understand in one-to-one context how those will actually form and how they will look. Manufacturing floor layout, so layout and factory plant planning, so how from an optimization point of your factory floor, how will this fit, how will this work, and obviously all the associated health and safety aspects that sit alongside that. Virtual training, very relevant, particularly in the whole concept of reuse. So being able to reuse that information that created all the way back in design process, to be able to see that to training people in the field or prior to obviously entering the field. So they've got that information of what to expect on site. We have some real good use cases there, particularly around things such as the oil and gas industry from a safety perspective, understanding what's actually happening before they arrive on site to conduct any repairs or installation work within there. Contextual digital twin, which is very relevant certainly in today's connected world. how we're seeing IoT data linked to real-time, essentially real-time aircraft, real-time ships, real-time factory layouts, so you can actually visually see what is happening and what are the conditions of parts within the virtual world. It's part of that as well. And then the other kind of, I suppose, the final elements of this really is how does that extend just beyond that manufacturing base? So how do you start to look into collaborating with suppliers, bringing their information into your model, understanding and having relevant conversations about some of the challenges that you're seeing as part of this build or design process. And on the final element of that, how do you actually mobilize, should I say, your sales force into being able to go out there and actually show this information to some of your clients and customers based on actually something which is tangible, something which is real, and something which the clients can engage with and see. So there's some of the kind of the key use cases which we have around this. Kashul, who's up next, he's going to talk through some of those, an example, and walk through some of those scenarios. So over to you, Kashul.